A bee returns to the hive with a secret. Somewhere outside, maybe beyond a line of trees or across a field, there is food, a patch of flowers rich with nectar, bright with pollen, valuable enough to be worth the trip. But the hive is dark, the comb is crowded. There are no maps on the wall, no spoken words, no pointing fingers, and no GPS signal. So the bee does something that sounds almost impossible. She dances, not a random little wiggle, not a cute insect habit, a coded performance. In the darkness of the hive on the vertical surface of the honeycomb, a successful forager can tell her sisters where to fly, roughly how far to go, and whether the reward is worth their effort. The message is written in motion, vibration, scent, touch, and rhythm. To a human eye, it may look like a tiny creature shaking in circles. To another honeybee, it can mean fly this way for this distance, and you may find treasure. The most famous version is called the Waggle dance. It usually appears when the food source is far enough away that simply saying nearby would not be useful. The dancer runs forward in a short, straight line while rapidly vibrating her abdomen. Then she loops back around to the starting point, runs the same vibrating line again, loops back the other way, and repeats. The whole pattern looks like a figure 8 with a vibrating dash through the middle. That central dash is called the Waggle run, and it carries the core of the message. The first part of the code is direction. Honeybees use the sun as a compass. Outside the hive, a bee can see the position of the sun, and even when the sun is hidden behind clouds, bees can use patterns of polarized light in the sky. But the dance happens inside the hive, often on a vertical comb in near darkness. So the bee translates the outside world into an indoor map. Straight upward on the comb stands for the direction of the sun. If the dancer waggles straight up, the food is in the direction of the sun. If she waggles straight down, the food is roughly opposite the sun. If her waggle run is angled 60 degrees to the left of vertical, the food lies about 60 degrees to the left of the sun's direction outside. And the sun is always moving. Over the course of the day, its position changes across the sky. Honeybees compensate for that movement. A dance that points to a flower patch in the morning may need to shift later because the sun has shifted. This is one reason the waggle dance is not just a reflex. It is connected to navigation, memory, and an internal sense of time. The second part of the code is distance. The longer the waggle run lasts, the farther away the food source tends to be. This does not work like a perfect tape measure, and scientists are careful not to pretend that a bee is reporting distance with engineering precision. The relationship can vary between species, landscapes, wind conditions, and experimental situations. But the basic principle is clear. Short waggle runs usually mean a closer destination, and longer waggle runs mean a more distant one. A bee does not measure distance the way a car does. She does not count meters from a road sign. Her distance estimate is linked to the effort and visual experience of flight. As she flies, the world moves across her eyes. Nearby objects sweep past quickly, distant objects shift more slowly. This flow of visual motion helps the bee estimate how far she has traveled. The third part of the message is quality. A rich food source can produce a more enthusiastic dance, more repeated waggle runs, more attention-grabbing movement, more persistence. A weak source may get a few half-hearted circuits or no dance at all. A colony has limited workers and limited time. It cannot send everyone everywhere. The dance helps the hive focus effort on resources that are worth chasing. But the dance is not the whole message. Bees are not tiny robots receiving coordinates and flying in a straight line until they land on a flower. The dancer also brings back scent from the flowers she visited. Followers may touch her with their antennae, taste a sample of nectar, sense vibrations through the comb, and pick up floral odors. The dance gives a direction and a rough distance. Smell and local searching help finish the job once recruits arrive in the right area. That detail matters because scientists long debated how much information the dance really carried. Karl von Frisch, the Austrian biologist who decoded much of the dance language, argued that bees use it to communicate direction and distance. His work became one of the great discoveries in animal behavior, and he shared the 1973 Nobel Prize in Physiology or Medicine for studies of individual and social behavior patterns. But not everyone was convinced. Some researchers suggested that odor might be doing most of the work. The answer turned out to be more interesting than a simple winner-takes-all argument. Modern experiments, including studies that tracked recruited bees as they flew, support the idea that bees do use dance information. Recruits often head off in the direction indicated by the waggle dance, but they do not always fly straight to the exact flower. They may reach the general area and then begin searching using scent, memory, and the landscape around them. The dance is powerful, but it is not magic. It narrows the world. Inside the hive, the followers have their own challenge. They are not watching the dance like people watching a stage performance under bright lights. The hive is dark, warm, vibrating, and packed with bodies. A follower must stay close to the dancer, often using her antennae to track movements. She may only follow part of the dance before leaving. The information can be noisy and imperfect. But in nature, perfect precision is not always necessary. A group of bees spreading through the right area can be more useful than one bee aiming at one exact point. There is also a simpler dance, often called the round dance, used mainly for food very close to the hive. In a round dance, the bee circles and changes direction without giving a precise long-distance bearing. The message is closer to, good food is nearby, search around the hive and use the scent. As the food source gets farther away, the dance tends to shift into the more directional waggle pattern. The boundary is not a hard switch in every case. Bee behavior is often a continuum, not a set of neat human categories. The waggle dance can also be used for more than nectar and pollen. Honeybees may dance for water sources. Swarms can use dances when choosing a new nest site. Scout bees inspect possible homes, return to the swarm, and advertise the best options. Other scouts check those sites too. Over time, through repeated dances and competition between alternatives, the group can move toward a decision. A swarm hanging from a branch may look chaotic, but inside that cluster, information is being tested, shared, and weighed. This is one of the most fascinating parts of bee communication. It is individual and collective at the same time. A single bee finds something. She returns and reports it. Other bees evaluate, follow, confirm, ignore, or compete with that report. No single bee understands the whole landscape the way a human mapmaker might. Yet the colony can behave as if it has a distributed map of opportunities. That does not mean bees have language in the human sense. They do not tell stories about yesterday, invent poetry, or discuss the meaning of life. The waggle dance is limited. It is mainly about location, value, and action. Yet within that limited world, it is astonishingly sophisticated. It shows that communication does not need words to be complex. A body moving in the dark can carry geometry. A vibration can point toward the sun. A few seconds of motion can redirect the labor of a colony. The dance also reminds us that intelligence in nature often looks unfamiliar. We tend to imagine intelligence as something with a face like ours, a voice like ours, and a brain built like ours. Bees challenge that idea. A honeybee brain is tiny, yet it supports navigation, memory, learning, time compensation, social signals, and flexible foraging decisions. The colony adds another layer, thousands of small minds linked by chemical cues, movement, touch, and shared work. The next time a bee lands on a flower, it may look like a tiny accident of nature. But that visit might be part of a much larger conversation. Somewhere in a hive, another bee may have already danced the path. She may have turned sunlight into an angle, flight effort into rhythm, and flower scent into a promise. And in the darkness, other bees may have listened with their antennae, followed the vibration, and flown out into the world. A waggle dance lasts only moments. The message can vanish as quickly as it appears. Yet from those moments, a colony can find food, choose homes, and survive changing seasons. That is the quiet wonder of the bee dance. Not that bees speak like humans, but that they do something just as remarkable in their own way. They turn movement into meaning and meaning into survival.
Thanks for watching! If you enjoyed the video, please like, subscribe, and leave a comment below. See you in the next one!